Well, the next topic we are covering is big data in banking. And today I'd like to begin our lecture by exploring how big data is transforming the way organizations make decisions in the digital age. And also, throughout this lecture, we will examine the fundamental characteristics of big data and understand its impact on human and machine decision-making processes, and also explore practical applications across various industries. Well, now let me introduce you to the concept of big data. I would like to start with the saying that it has fundamentally changed how we process and analyze information. And for example, in my experience working with financial institutions, I've seen how traditional database tools often struggle with the sheer scale of modern data sets. And for example, when we say big data, we are referring to data collections that have grown so large and complex that conversational processing applications simply can't handle them effectively. And for example, you can think about this. Every time you make a digital transaction, or for example, use social media or browse online, you are contributing to these massive data sets. And for example, the real challenge lies not just in collecting this data, but in the entire life cycle of data management, from, say, capturing and storing it to analyzing and visualizing it in meaningful ways. Well, let me walk you through some key sources where big data is being collected and warehoused. And in the financial sector, I regularly observe how data is accumulating from, say, multiple channels simultaneously. And for example, if we consider e-commerce, every purchase you make at the department store or grocery store, it generates data points. And for example, when you use your credit card, the transaction creates a detailed record that includes the time, location, amount, and also merchant information. And for example, web data is particularly interesting because it captures not just what you buy, but how you navigate through websites and make purchasing decisions also. And for example, I also find social networks to be especially rich sources of data, and because, for example, they provide insights into consumer behavior and also preferences and trends that were previously impossible to capture at the scale. And now let me explain what makes big data fundamentally different from traditional data. Let me do it through what we call the 4V properties. And for example, in my work with financial institutions, I found that understanding these characteristics is crucial for grasping why big data requires special approaches. And for example, when I discuss volume, I would like to emphasize that massive scale we are dealing with. We are expecting to reach 175 zettabytes of global data by by the end of 2025, up from 49 zettabytes in just 2019. And it seems to me as an unprecedented growth that requires entirely new approaches to data management. And another thing, which is velocity, is equally important because, for example, you could imagine processing millions of credit card transactions happening simultaneously and worldwide. And this real-time data flow now creates unique challenges for our infrastructure. And also, when I mention variety, I'm referring to how data comes in different formats, like, for example, structured like databases, semi-structured like XML files, and also unstructured like social media posts. And the fourth V which is veracity, is particularly critical in finance because we need to ensure data quality and reliability across all these dimensions. And for example, I've seen cases where poor data quality led to incorrect financial decisions, which is why we need robust data governance processes. And now let me explain why data volume is such a crucial aspect of big data. And especially in financial sector, of course. And now, for example, looking at this graph, I can show you the exponential growth trajectory we are experiencing in global data generation. And what you see here is a projection that makes us from our current position to an estimated 175 zettabytes by the end of 2025. And to put this in perspective, for example, when I first started working with financial data analytics, we were measuring data in terabytes. But now we have moved far beyond that scale. And for example, let me give you a practical example from banking. In just one day, a large international bank, for example, processes more transaction data than it did in an entire year a decade ago, just a decade ago. And this massive volume presents both opportunities and challenges, of course. And now let me illustrate the concept of velocity in big data through this revealing diagram that shows the evolution of data, process, and speeds. For example, when I look at these statistics, they paint a striking picture on how rapidly data is being generated in our digital world. For example, just consider these numbers. Every minute, we're seeing 100,000 tweets, 700,000 status updates, and also 11 million messages being sent. And for example, in my experience, this velocity creates both opportunities and challenges for real-time decision making. And let me give you a practical example of this. For example, when you make a credit card purchase, the system needs to analyze your transaction pattern and to verify available funds, for example, and check for potential fraud, and all within milliseconds. And the progression we see in the diagram, for example, from personal computers to social media and IoTs, represents how we've moved from batch processing to real-time data streams. And now let me explain the three main types of data variety we encounter in financial services and why understanding these distinctions is crucial for data analytics. For example, looking at this diagram, I will try to walk you through each type. And I frequently deal, for example, with structured data. For example, you can think about transaction records in databases where, say, everything fits neatly into rows and columns with clear parameters. But for example, when you look at const statements, each transaction has a specific date, amount, and category. And now moving to semi-structured data, this is where things get more interesting. And for example, in my experience, a perfect example of email communications with clients, they follow certain patterns with metadata like sender, recipient, timestamp, for example, but the content itself isn't rigidly structured. And the most challenging category is unstructured data, of course, because I encountered this when analyzing customer feedback, for example, through social media posts or call center recordings. And here is a practical scenario. For example, you could imagine trying to understand customer sentiment about a new financial product, and you would need to analyze structured data from sales figures and semi-structured data from email inquiries, and also unstructured data from social media comments and all require a different analytical approach. And now let me explain why veracity is perhaps the most critical aspect of big data, especially in financial services. For example, looking at this diagram, I can show you the 6 key dimensions that determine data reliability. For example, I emphasize that accurate data is our foundation, and even a small error in financial data can lead to significant consequences. And for example, if you let me give you a real world example from my experience, so especially in risk assessment, for example, if customer income data is inaccurate or incomplete, it can lead to improper credit decisions. And consistently across different systems is equally crucial because, for example, I've seen cases where the same customer had different credit scores in different databases, creating confusion in decision making, of course. The uniformity of data formats helps us integrate information effectively. For example, you could imagine trying to analyze transaction data where dates are recorded in different formats across systems. And also looking at this graph, I will help you understand the hierarchy of data sources that organizations typically use in their big data initiatives. For example, transaction data leads at 92%, which aligns with my experience in financial services because it's the most structured and readily available data source. And now let me explain why this makes sense. Because, for example, every financial institution processes thousands or millions of transactions daily. That is creating a rich data set for analysis. And for example, following closely is log data at 81%, which I find particularly valuable because it captures system interactions and user behaviors. And for example, when I worked with banks, log data helped us understand customer journeys through digital banking platforms. And for example, event data shown at 70% represent specific actions or occurrences. And you can think about credit card swipes, for example, or ATM withdrawals or online banking logins even. And I also find interesting here is how emails rank 4th at 65%. And as to my opinion, demonstrating the growing importance of unstructured communication data in understanding customer needs, and so on. And now let me walk you through this decision-making pyramid that illustrates how humans process information in order to make decisions in financial contexts. And for example, in my experience, I find this framework particularly useful for understanding how we transform raw data into actionable decisions. And for example, at the base of our pyramid, we start with data, and there are raw facts and statistics that surround us in the financial world. And for example, as for a practical example here, please imagine all the individual credit card transactions a bank processes. So this is pure data, just numbers and timestamps without context. And for example, moving up to the second level, we transform this data into information by processing and organizing it meaningfully. And in our credit card example, this might mean aggregating transactions by merchant category or time of the day. And the third level, which is knowledge, is where human experience becomes crucial. And this is where we apply our understanding of past patterns and market behaviors to interpret the information. For instance, a sudden increase in transaction simply declines might signal a potential fraud pattern that an experienced analyst would recognize. And now let me explain how machine-generated decision and decision-making differs fundamentally from human decision-making. as illustrated by this simplified two-layer pyramid. And what I find particularly interesting is how the process is compressed compared to the human decision-making model we just discussed. For example, in machine learning systems, we start with data just as humans do, but there is a crucial difference, which is the data needs what we call markups or labels. And now let me give you a concrete example from financial services. For example, when we are building a fraud detection system, we need to feed it historical transaction data where we've already marked with which transactions were fraudulent and which were legitimate. And this labeling is essential because it's how machines learn to recognize patterns. And the fascinating part of what it happened next, that is the machine moves directly from data to decisions, keeping the intermediate steps of information processing and knowledge accumulation that humans use. And for example, we often call this direct jump a black box because the internal decision-making process can be quite opaque even to us who design these systems. And also in my experience working with various industries, I've observed how big data analytics has become a fundamental driver of decision-making processes. For example, let me walk you through 4 key areas where we're seeing a significant impact. First, machine learning capabilities have transformed how we process and learn from massive data sets. And for example, without explicit programming, systems can now identify patterns and make predictions that would be impossible for humans to detect manually. And for example, when we look at the Internet of Things, we are dealing with an interconnected network of physical objects that continuously generate data. And this network also provides real-time insights into operational efficiency and also maintenance needs and also resource utilization across industrial applications. And in the realm, especially of product development, we are now able to mine customer reviews at scale. And this allows companies, for example, to understand customer preferences and ultimate their estimation willingness to pay for specific features and also leading to more targeted product development cycles. And now let me explain the 4 essential components that make big data analytics work effectively in practice. And these components form an interconnected system that drives value creation from data. And for example, at the foundation, we have a data itself. And working with big data requires a sophisticated approach to handle large, diverse data sets. And for example, in my work with financial institutions, I've seen how critical it is to maintain data quality and ensure different data types that can work together seamlessly. You must also be able to adapt quickly as new data sources emerge. And the technology component is equally crucial because when implementing big data solutions, organizations need to invest in specialized technologies and like, for example, Hadoop or NoSQL databases, also cloud computing and so on. And moving to analytics, we leverage advanced techniques like natural language processing or network analysis and also artificial intelligence. And these tools are essential because they help us handle the variety and volume of big data while managing its inherent volatility. And finally, at the top level, we have decisions. And for example, this is where everything comes together, and the insights we generate through analytics drive decision-making at all levels, from operational choices to strategic planning. And in my role, for example, teaching advanced analytics, I find it valuable to outline the key analytical techniques that modern processing power has made possible. And let me guide you through this fundamental approach that form the backbone of big data analysis. And for example, when I examine relationships between variables, regression analysis, and so on becomes our primary tool. And I often use examples from financial markets where we might analyze how interest rates affect consumer spending patterns, for example, or time series analysis takes this further by revealing how these relationships evolve over time, and particularly useful when, for example, we are studying market trends or economic indicators. And also in predictive modeling, we use historical data in order to forecast future outcomes. And for instance, in credit risk assessment, we analyze past borrower behavior in order to predict future default probabilities. And this connects closely with classification, where we organize data points into non-categories. Like, for example, you can think of how we segment customers based on their credit profiles. And now let me walk you through the analytics maturity curve that shows how organizations progress from basic reporting to advanced decision-making capabilities. And this framework has proven invaluable in my experience working with the financial institutions. And we start from descriptive analytics, which answer the question, what happened? And this also forms our foundation, which is examining historical data to understand past performance. For example, when analyzing credit card transactions, we look at spending patterns and transaction volumes over time also. And moving up the curve, we reach diagnostic analytics, which help us understand why did it happen. And here we identify the root causes of trends and outcomes. And for example, in financial services, we might analyze why certain investment products performed better than others, or what factors led to increased customer churn. And this also provides insight into cause and effect relationships. And as we progress to predictive analytics, we ask what could happen. And for example, using historical patterns, we can forecast future outcomes. And in risk management also, we use this in order to predict potential loan defaults or identify customers likely to need certain financial products. And this gives us foresight into potential future scenarios. And the highest level also, prescriptive analytic answers the question, what should be done? And this is where we recommend optimal actions or decisions. And for instance, determining the best time to launch a new financial product or adjusting investment portfolios based on market predictions. And this represents optimization of our decision-making process. And now let me share with you 4 key applications of big data analytics that are transforming marketing decision-making in the financial sector. Now, for example, I've seen these approaches create significant value across multiple organizations. So let us begin with the sentiment analytics. For example, when working with financial institutions, I've observed how monitoring customer sentiment has become crucial for example, marketing success. And also by analyzing social media posts or reviews and customer feedback, we can understand how customers feel about our products and services in real time. And this helps identify key customers who have become brand advocates and also boost word-of-mouth marketing. And the customer 360 approach represents a complete view of customer behavior. And for example, in banking, we compile data from various touch points, like, for example, mobile apps, branch visits, call centers, and online banking also. And in order to build comprehensive customer profiles, and this allows us to understand product engagement patterns and, importantly, detect early warning signs when a customer might be considering leaving for a competitor. And customer segmentation has evolved significantly with big data. And for example, instead of broad demographic categories, we now create precise micro segments based on behavioral patterns. And for example, in my experience with credit card companies, this enables us to design highly targeted marketing programs and loyalty rewards also. And we can optimize also pricing strategies for different segments and build stronger relationships with our most valuable customers. And finally, the next best offer capability uses predictive analytics to enhance customer loyalty through personalized recommendations. And for example, by analyzing transaction patterns and customer behavior, we can determine which products or services a customer is most likely to need next. And this approach has proven particularly effective in cross-selling financial products and increasing revenue through strategic product bundling. And also in my work with financial institutions, I found that social media analytics has become an indispensable tool for understanding market dynamics. And let me explain how this works in practice. For example, banks and financial institutions are now systematically gathering data from multiple social platforms like X or Twitter, former Twitter, Facebook, and various blogs networks. And what makes this particularly powerful is that the real-time nature of the data collection. For example, unlike traditional market research that might take months to complete, social data provides immediate insights into how customers think and behave. And when analyzing the social data, we look for several key indicators like we track sentiment around specific financial products and monitor discussions about banking services and also identify emergent trends and customer preferences. And for instance, when a bank launches a new mobile banking feature, we can immediately coach customer reactions and also adapt the rollout strategy accordingly. And one of the most valuable aspects I've observed is the ability to understand buying patterns. And for example, by analyzing social conversations, we can identify what triggers customers to switch banks and what features, for example, they value most in financial products and what pain points also they experience in their banking relationships. And also this information is especially valuable for retailers and financial institutions in designing targeted marketing campaigns. And now let me share with you two prominent examples of how leading companies are transforming their businesses through big data analytics. And I also want to highlight the clear connection between business needs, analytical solutions, and measurable impact. The first case is Capital One's innovative approach to credit card marketing. The matter is that they developed a sophisticated statistical model that analyzes public credit cards and demographic information. And this enabled them to create highly personalized credit card offers that precisely match customer needs. And the results were remarkable because they achieved a compound annual growth rate of 32% in net revenue. And this success was so significant that it actually prompted their competitors to fundamentally shift their focus toward data and analytics. And the second example demonstrates how General Electric is revolutionizing the transportation industry through the Internet of Things. For example, GE developed specialized software that helps airlines and railroads migrate their operational data to the cloud. And this system can predict merchant and malfunctions and also enhance safety protocols and minimize trip cancellations and while reducing operational costs. And the impact is substantial. They project a 1% reduction in fuel costs, which translates to approximately $30 billion in savings for the airline industry over a 15-year period. And in this section, I would like to walk you through 3 compelling real-world examples of how financial institutions are using big data analytics in order to enhance their customer service and engagement strategies. First, please consider the case of a Canadian credit card issuer that wanted to improve their offer targeting. For example, by integrating their complete customer data sets with additional parameters into their analytics framework, they achieved remarkable results. For example, their models now run 25 times faster than before. And more importantly, they've seen a 40% improvement in customers' response rates to their offers. And the second example comes from a multinational European bank that focused on anticipating customer needs. And for example, they implemented a system analyzing various customer touchpoints, for example, transactions, payments, and channel interactions in order to deliver real-time offers. And these results speak for themselves because they achieved a 50% better response rate in offers and saw a 98% increase in client interaction metrics. And the third case involves a North American retail bank that tackled customer service efficiency because they analyzed call center notes and website clickstream data in order to identify common issues and anticipate customer inquiries. And through this approach, they successfully resolved issues related to 11% of their call center inquiries and significantly improving their customer service efficiency also. And now let me guide you through several practical applications of big data analytics and risk management and fraud prevention at major financial institutions. Let's start with an Australian retail bank's approach to credit assessment. Well, they implemented an innovative system that analyzes payment patterns, spending changes, and channel interactions to identify early indicators of credit worthiness and financial stress. And this comprehensive analysis enables them to reduce credit losses while optimizing their capital utilization. And a particularly increasing case of a US mortgage provider who transformed their collections process, and they developed a sophisticated system that extracts insights from multiple data sources like recorded calls, agent notes, payment histories in order to predict recovery likelihood and guide collection actions. And this data-driven approach resulted in a significant improvement in collections, generating an additional $50 million per year. And the third case I want to share is from a UK retail bank focusing on payment fraud prevention. And for example, they enhanced their real-time transaction analysis capabilities in order to examine a large percentage of payments. And this proactive approach helps them prevent 300,000 to 500,000 in fraud-related losses every month. And now let me explain how big data analytics involves from basic data collection to predictive capabilities through a systematic process that we can break down into 4 key stages. Well, the process begins with data collection, where we gather raw data from various sources. And you can think of this as casting a wide net in order to capture all potentially relevant information. For example, at this stage, our data is unstructured and contains both valuable insights and noise. And moving to the second stage, we clean and organize this raw data in what we call hindsight analysis. And this is where we transform the scattered pieces of information into a coherent, usable data set. And this stage is crucial because the quality of our analysis can only be as good as the quality of our data. And in the third stage, we identify patterns through insight analysis. And this is where we begin to see relationships and correlations emerge from our cleaned data. Well, we are looking for meaningful patterns that can help us understand underlying trends and also relationships. And finally, we reach the foresight stage where we use these identified patterns to make predictions about future trends. And this predictive capability is what makes big data analytics particularly valuable for business decision making. And we're not just looking at what happened in the past, we're using that information to anticipate what might happen next. And now let's walk you through the sophisticated process of how big data analytics helps detect fraudulent activities through pattern recognition. And this is a 5-step approach that transforms raw data into actionable fraud prevention insights. When we begin by encoding relationships as network graph data. And in this step, we take various data points like customers, materials, vendors, and map out how they are interconnected. And each node represents an entity, and the lines between them show their relationships. For instance, a customer might be linked to multiple transactions, which in turn connect to various vendors. And next, we generate and visualize these networks on a larger scale. And this gives us a comprehensive view of all transactions, whether they are between people, transactions, or even property. And the resultant visualization might look complex, but it's actually helping us see patterns that would be impossible to detect in raw data. And in the third step, we identify what we call normal and unusual clusters. Normal patterns of behavior tend to form certain types of clusters in our network. And when we see clusters that don't match these typical patterns, they warrant closer investigation. And the fourth step involves identifying potential partners and chains of activity. And for example, we are particularly interested in sequences of transactions or relationships that might indicate fraudulent behavior. And this often appears as distinctive chains in our network visualization. And finally, we search for both known and new patterns of rules. And we compare what we are seeing against established fraud patterns while remaining alert to new emerging forms of fraudulent activity. And this dual approach helps us stay ahead of evolving fraud techniques. And this systematic approach enables financial institutions to detect and prevent fraud from more effectively than traditional methods. And now let me explain what our data analysis reveals about why customers leave their banks and how we can use this information to prevent customer attrition. And these statistics I'm showing you come from comprehensive research into customer behavioral patterns. Well, customer service emerges as the dominant factor, accounting for 70% of customers' departures. And this remarkably high percentage underscores how crucial service quality is in banking relationships. And for example, when we dig deeper into the transaction data, we often find that service-related issues manifest long before a customer decides to leave. and especially through patterns like increased complaint frequencies or reduced interactions with the bank services. And also, quality of banking products and services is the second most significant factor at 30%, while pricing concerns drive 24% of customer departures. And these percentages tell us that customers often value service quality more than price points, which challenges the common assumption that competitive pricing is the primary retention tool. And also, functionality of banking services accounts for 13% of departures, while both convenience and change in needs each represent 8% of customer exits. And this low percentage suggests that most banks are meeting basic functional requirements, but maybe falling short on the human elements of banking relationships. Well, now let me explain the 5-stage process cycle of people analytics that HR department used to make data-driven hiring decisions. And this systemic approach helps organizations predict which candidates are likely to become high performers. It all starts with asking the right questions. And in this first stage, we need to clearly define what we are looking for potential candidates. And we might ask, for example, what skills and experiences correlate with success in similar roles? And what behavioral patterns indicate long-term potential? And these questions guide our entire analysis process. And the second stage involves data selection. For example, here we identify and gather relevant data sources like past recruitment records and job posting response metrics, and also performance evaluations, and even external data like Glassdoor ratings. And we need to be selective about which data points will truly help us predict future performance. And also, data cleaning is our third stage, and it's absolutely crucial. For example, raw HR data often contains inconsistencies, missing values, or outdated information also. We need to standardize formats, remove duplicates, and ensure data quality before any meaningful analysis can begin. And in fourth stage, we conduct our data analysis and we look for patterns and correlations between candidate characteristics and eventual job performance. And this might evolve to analyzing successful employees' career trajectories, identifying common traits among top performance, or studying factors that predict long-term retention. Well, and now let me explain how modern banks are transforming their marketing approaches through sophisticated data analysis and predictive modeling. And what's particularly interesting about this transformation is how it combines multiple types of customer data and create highly targeted marketing campaigns. Well, at the core of this approach is the application of algorithms and statistical models that analyze three key data streams. For example, customer transaction history, demographic information, and also channel preferences. And you can think of it as creating a three-dimensional view of each customer. For example, when we combine these data streams, we can understand not just what customers do, but why they might do it and how they prefer to interact with the bank. And also, the real power comes from using the comprehensive data analysis to segment customers into what we call micro segments. And for example, unlike traditional broad demographic segments, these micro segments capture nuanced behavioral patterns. And for instance, we might identify a segment of customers who primarily use mobile banking on weekends, for example, for international transfers. And this level of detail allows us to predict their behavior with much greater accuracy. And what makes this approach particularly effective is how enables banks to batch their marketing messages and offers to specific customer needs and preferences. For example, if our analysis shows that the customer frequently makes international payments through, say, desktop banking, we might target them with an offer of a premium international account service delivered, say, through their preferred channel at their most active time. And now let me explain how financial regulators are using big data analytics to monitor market risks in real time. And this represents a significant advancement in how we maintain market stability and detect potential systemic risks. The process begins with the analysis of high-frequency trading data. And for example, the volume and velocity of modern financial markets generate massive amounts of data every second. And also, regulators now have the capability to capture and analyze this data stream in real time, which give them unprecedented visibility into market dynamics. And for example, you can consider that in just 1 minute or millions of trades might occur across markets, and each one potentially containing signals about market health. And what makes this particularly powerful is how regulators can now analyze relationships between different financial instruments. And they're not just looking at equities in isolation, but they are examining the complex web of relationships between equities, derivatives, and even cryptocurrencies. And this interconnected view is crucial because in our modern financial system, risk can propagate rapidly across different asset classes and markets. And now let me explain the key responsibilities of a Chief Risk Data Officer, or CDO, in modern organizations. The CDO role has emerged as a critical position that bridges the gap between data capabilities and business strategy. And for example, in terms of data ownership and strategy, the CDO leads the so-called data-driven transformation across both offline and online retail channels. And this involves consolidating data from various parts of organizations, and you can think of it as creating a unified view of all data assets. And the CDO also identifies and implements the most effective analytics tools in order to support the organization's objectives. And this role is particularly crucial in financial institutions where data strategy directly impacts business outcomes. And the data monetization aspect is equally important because the CDO oversees how teams analyze data and generate insights from both offline and online channels. And they're responsible for ensuring that data assets are not just collected, but actually create tangible value for the organization. And this might involve developing new data-driven products or optimizing existing services. And now let me explain how cloud computing fundamentally transforms our ability to handle big data analytics in financial institutions, and why this matters for our scalability and innovation capabilities. Well, cloud solutions have revolutionized how we approach data storage and also processing by providing what we call elastic compute and storage capabilities. You can think of elasticity as having a rubber band that can stretch or contract based on your needs. For example, when you experience sudden spikes in data processing requirements, perhaps during end-of-day trading or a month-end reconciliation, cloud platforms can automatically scale up resources. And then, when demand decreases, these resources scale back down, ensuring we only pay for what we use. And the economic efficiency of this model is particularly significant for financial institutions because rather than investing in expensive on-premises infrastructure that needs to be built for peak capacity but sits largely idle most of the time, cloud solutions allow us to match our resource utilization precisely to our actual needs. And this represents a fundamental shift from capital expenditure to operational expenditure in our technology investment. And now let me walk you through the maturity curve of analytics capabilities in organizations. And this progression represents how institutions evolve in their use of data analytics, moving from basic reporting to increasingly sophisticated applications. And the journey begins with fundamental data management, which is raw data collection and cleaning. You can think of this as establishing the foundation. And organizations start by gathering data and ensuring its quality and consistency. And this enables basic standard reporting, which answers simple questions about what happened in the past. And as organizations mature, they develop ad hoc reporting capabilities and begin using online analytical processing or OLAP tools. And this represents a shift toward more flexible analysis where users can drill down into specific aspects of the data. And the next step brings self-service business intelligence and agile visualization tools empowering users across the organization to explore data independently. And now here's where we encounter what we call the chasm, which is a significant leap in capability that many organizations find challenging to cross. And now let me explain a crucial perspective on the future direction of decision-making processes. And as I analyze industry trends, I see a clear movement toward what we call hybrid analytics, which is a synergetic combination of human judgment and machine capabilities. And for example, in my experience working with financial institutions, I have observed that the most effective approach isn't pure automation or purely human decision making. Instead, I want to emphasize that leaders will increasingly make strategic judgment calls while leveraging AI support systems. And what makes this hybrid model particularly powerful is how it combines human intuition and experience with technology's ability to process data at unprecedented scales. For example, when I work with investment teams, I see how portfolio managers use their expertise to set strategic directions while AI systems execute complex calculations, for example, and monitor multiple market signals simultaneously. And I also regularly encounter 6 major challenges in leveraging data effectively for decision making. And the first issue I frequently see is persistent data quality problems. While incumbent institutions possesses vast financial data sets, I've noticed they often struggle with inconsistent formatting. For instance, when I worked with a major bank, their customer data was stored in multiple formats across different systems, making it difficult to create a unified view. And a related challenge encounters the fragmentation of data storage. For example, in my consulting practice, I've seen how financial institutions store their data across numerous disparate systems. This also creates what I call a patchwork effect, which is making it extremely difficult to get a comprehensive view of the data. And another critical limitation I've observed is insufficient breadth and depth of data. And for example, when implementing major AI applications, I found they require insights that span across multiple data sets. For example, to effectively assess credit risk, we need to combine traditional financial data and alternative data sources. Well, and now I would like to summarize the fundamental concepts we've covered in this lecture about big data role in decision-making processes. And from my experience in implementing these systems, I have identified several critical points that I wanted to take away. First, let me emphasize how big data fundamentally transforms decision-making through its 4 key characteristics like volume, velocity, variety, and veracity. And as someone who has worked with financial institutions, I can tell you that this combination enables decisions that are not just faster, but substantially more informed. And for example, when I look at the evolution of analytics, I see a clear progression from descriptive to prescriptive models. And this power lies in how predictive models allow us to plan proactively, while prescriptive models guide us toward optimal decisions. And for example, in financial services, I've seen how this progression has revolutionized everything from risk assessment to customer service. And let me also share a practical perspective on infrastructure. Cloud computing has become absolutely essential because it provides an elastic scalability needed to handle variable workloads. And I've also seen organizations struggle with their on-premise solutions before embracing cloud technologies, and the difference in capabilities is substantial. And I also want to be clear about one critical point, which is success with big data isn't just about technology. Because, for example, in my consulting work, I've observed that organizations need three key elements: a data-driven culture, robust governance frameworks, and strong security practices. And these organizational aspects are just as important as the technical infrastructure. And looking ahead, I believe the future of decision-making will increasingly involve human AI collaboration also. And the key is understanding how to leverage technology scalability while maintaining human oversight and judgment. Well, and we have come up to the quiz. Please read the question. Which aspect of big data analytics infrastructure enables the most economic storage and compute scalability to handle exponential data? And please choose one of the proposed answers. Please take a couple of minutes for that. Well, I can see your answer. The majority of answers is 2. Yeah, the second answer is right, quite right. So great. Okay. By the end of the lecture of this topic, we have issues for discussion, but to my sorrow, we do not have enough time for that. That is why I will skip that issues, but you can turn back to them afterwards, after the lecture. And here we have a glossary also.